Okay, compound interest. A little different from what we were talking before, simple interest. Compound interest has a different concept. Like we talked about before, we had simple interest. We did a really simple question where we said we had $100 of principal. Okay, and we put that in. That was our present value. Put $100. We were earning 10% annually. Okay, and we put it in for 5 years. With simple interest, we end up with $150 in the end, correct? Do you remember that? Earn $10 every year for 5 years, $50 plus $100, $150. This is a little different. Now, what's also different is we have two new variables. And these two variables also have two new definitions. I equals R divided by C, N equals YR times C. We need to start defining what some of these things are. Now, lowercase r, do you remember what it was? The interest rate. And for some reason I wrote $10. It's definitely not $10. It was 10%. Okay. Now that was our R. And these are our years. Okay. Now, we're going to say it's compounded. In fact, yeah, we're going to change it a little. What they'll do is they'll say something called compounded. Okay. And what that means is how often they compound something. Compound it, and we're going to say quarterly in this one. Quarterly. Do you know how many times a year quarterly is?
4.
4. These are very important. So let's get some, let's kind of draw some things together. So $100 stands for what?
Principal.
Principal. So our P, $100. That's what $100 for. R stands for what?
Interest rate.
R, interest rate. Actually goes there. It doesn't go into our equation. Okay. 5 years stands for? Just YR in this case. A little different. Okay. YR. Again, doesn't go into our formula. It's here. Compounded quarterly. So we said it was the number 4. So 4 is equal to what? What letter do you think we're using? C. That's our compound period. 4 is equal to C. It's quarterly. And C goes here. Now with C, if you notice, then once we have this information, we have a number for N, and we have a number for I. And then we'll have all the variables to solve for A. So we actually have to do a little equating before we get into it. So I is the interest rate per compound period. Okay, and the reason I want you to get used to this is I is equal to, our interest rate was 10, which is 0.1, divided by the compound period of 4. So let's get used to this idea. What is that number?
0.025.
Okay. So I is equal to 0.025. What that means is you get 10% annually. Well, if you add up 0.025 you multiply it by 4, you're going to get 0.1, which is a 10% annual rate. But 4 times a year, so every 3 months, you're going to get this much interest. This is actually 2.5% interest, okay? Every 3 months, you get 2.5% interest, so you earn a little bit of interest. And then 3 months after that, you earn a little bit of interest, but you earn it on all the money in the bank. So because every 3 months you get a little more and a little more, you actually get a little bit higher than 10% a year because it's compounding. And the faster something compounds, the more money you're going to get towards the end of the year. The higher above the annual rate, they call it, the higher above that annual rate you'll be. And you'll see, because if it was the annual rate we were going by, we should only get this kind of roughly $150. We're going to get a little more than that now. And this is how usually banks and savings accounts do money. Okay, so we have our I. So I'm gonna leave. I'm not gonna put any more colors to get confusing. And the other thing we got to figure out, N. N stands for number of periods. Kind of like T did, but this one is definitely because we're multiplying the years times a compound period, right? So if it's 5 years and we get it 4 times a year, that's right. So that's 5 times 4. Not 20 years, but 20 periods. So now we have a number for N. So let's do compound interest. So A is equal to, the principal we had was $100. 1 plus I. I is equal to 0.025. We'd already figured that out. To the power of 20. A is equal to 100. We don't have to put dollars. Times 1.025 to the power of 20. Now, what do we do first? The multiplication or the exponent? Yeah, that's right. We do the exponent. So 1.025. Not times. 1.025 to the power of 20 equals a very large number. Well, sorry. Not large, but a very long decimal. Instead of writing this decimal in, I'm just going to go to the next step on my calculator and multiply it by my 100. So we now earned, after 5 years, we earned $163.86, which is about almost $14 more than our simple interest we had before. Okay? So compounding, because we were getting interest on money we'd earned as interest, we earn more and more and more interest every single year. So the longer we let it sit, the more interest we earn on this account. And that's what compounding interest is. And that's what savings account usually lose. All types of companies. If you're getting interest rates, credit cards charge people this way. The longer you accumulate interest, the more interest you earn.